Hello everybody, welcome back. This is lesson 4 of our unit 10. Today we're going to continue practicing conjugate acid-base pairs. Yesterday we spent some time practicing it. We introed the topic 2 days ago. So the way it's best structured is if you work on the practice questions yourself and then check back in with the video to kind of go over them and hear explanation. So, tonight you should have the conjugate pair Bronsted, Larry, Castle Learning due tonight by 11:59. Again, make sure you're checking the schedule because the day that this is being recorded is not the day that you are watching it. Okay, so jumping into questions. Number 1 says, according to one acid-base theory, water acts as an acid when H2O. Now we're talking about, the answers are talking about H plus and H minus. These things we haven't talked about, so no. One thing you should be thinking of is bad, and this means bases accept, acids donate, and we're talking about H plus. And this is what Bronsted Larry said about acids and bases. He said that bases have the capability of accepting H pluses and acids have the capability of donating H plus. So we're talking about water as an acid, means we're talking about donating H plus, which is answer choice B. Number 2 asks which has your acid base, your acid and your conjugate base. So we're looking for pairs. Now, I've said this before when we're talking about conjugate pairs, think about how you're conjugating verbs in French or Spanish or Italian. They all have a similar stem and then the endings change, but you can tell that they're part of the same family. So you want to look for something that is part of the same family, so the pairs look very, very similar. The only thing that should be different from these pairs is one H. So I just highlighted those pairs for you there. So even before thinking about looking into what's acid, what's the base, what's the conjugate acid, what's the conjugate base, finding your pairs first. Because 9 times out of 10, that can give you the answer right off the bat. And it does. So B, C, and D are wrong because they're not paired properly. So we're going to look into this in more detail so we know we got the right one. In order to go from HSO4 to SO4 T-, you had to lose or donate an H+. And again, looking at bad, if you can donate or lose an H, that makes you an acid. And then when you actually do that donating, that is a conjugate base. And then if we're looking at the HPO4 T- to H2PO4, in order to get from one to the other, you had to gain or accept an H+. And if you have the capability of accepting an H+, that makes you a base, and that makes what you look like after you've actually accepted it, a conjugate acid. But again, as long as you could just pair them properly, that is how you can get those answers. Number 3. Again, you want the acid-base pair. So you want to find the things that pair together and look similar to one another. And just doing that alone knocks out choice A and B and C, leaving you only with D. If you were to further look into this, we could see that going from NH3 to NH4, you have to gain or accept an H+, which makes this your base and this your conjugate acid. And in order to go from H2O to H to OH-, you have to donate an H+, making this your acid and this your conjugate base. Again, just pairing them properly is enough to get the question. Okay, number 4, talking about given the reaction, the Bronsted Larry base for the forward reaction is, means we're just focusing on this one. The fact that it says forward reaction, don't let that throw you. So you want to figure out which one of these two is the base. So your first thing is to find your pairs. And at this point, I hope finding the pairs is easier than it was a few days ago. So looking at H2O to H3O+, you have to accept an H, which makes this your base and this your conjugate acid. In order to go from HCl to Cl-, you need to donate an H+ and get rid of it. So that makes this your acid and this your conjugate base. So if we're looking for the forward reaction, we're essentially just boiling our answers down to H2O and HCl. And then once we've figured out all that, H2O is your base. Another way you could have done this is just look at the reactants, and then one of the tables on your reference table, either L or K, I always mix up those two, says HCl is an acid, though that couldn't possibly be your answer. Okay, moving forward, number 5. It says, according to this, the water acts as, so we want to figure out if this is a base or acting as an acid. So, if we find that pair, in order to go from H2O to OH-, this needs to donate or lose an H+. And when you donate an H+, remember that makes you an acid, and this is your conjugate base. So we know it has to be an acid. And then it says receiving a proton or donating a proton. Remember, H+ is the same thing as a proton, and it's an acid if you donate a proton, so that makes it choice B. Number 6 says, ask me which are the two bases. So again, one of your first steps is finding your pairs. So there's one. Here's another one. So we're going to follow the red to go from NH3 to NH4. You have to accept an H+. And if you're accepting an H+, that makes you a base, and that your conjugate acid. If we go back to the H2S example, to get from H2S to HS, you have to lose or donate an H+. If you are losing, that means you are, or donating, that's an acid, making HS- your conjugate base. So when the question asks which two are your bases, NH3 is acting like a base, and HS- is acting like a base. So that is answer choice A. Okay, moving forward. What is the conjugate acid of H2S? Remember, a conjugate acid, you're just adding one more H+. So conjugate acid has one more H than this one does. So if you want to you only have one H here, it means you want to have two H's, and you still want to keep S, 1S, and 4 O's. So the only option with two H's, 1S, and 4 O's is choice A. Number 8, again, we're looking for the pair. So finding the pair is the easiest part, and then labeling them gets a little bit more challenging, but you guys can do this. So those are your pairs, NH3, NH4, and then H2O and OH. So that in and of itself gives you enough info to find the answer. So they're not asking you to find which and to label them, as long as you can just identify the pair. And again, the pairs look somewhat similar. If, though, we wanted to look into this in more detail, H2O to OH, you have to donate or lose an H+. So if you're losing or donating an H+, that makes you an acid, and this your conjugate base. And then if we go back to the NH3, NH4 pair, in order to get from NH3 to NH4, you have to accept an H+, which makes that a base, and this your conjugate acid. That didn't help answer the question, but going over this a bunch of times, eventually it will click into your head. Okay, number 9. Given the balanced equation representing a reaction, the water molecule acts as a base because, so again, if we want to just focus on this water, we can, if we want to, this is another pair. So in order to get from H2O to H3O plus, you have to gain or accept an H plus. Okay? So if you want to talk about, so that makes it, has the ability to accept an H plus. That is what BAD stands for. So again, bases accept, acids donate. This H2O has the ability to accept an H later on. When we're talking about OH minus, this is the other theory. This is Arrhenius' theory of bases. But when we're talking about this equation, OH doesn't even play a part in it at all. Okay, number 10. Asking for the conjugate base of that. A conjugate base, you have one less H plus. So here you have 4 H's. If you have one less H, you'd have NH3, and A is the only option. So again, if we're talking about conjugate acids or bases, the only difference between that and its pair is 1 H. So that's why B, C, and D make no sense whatsoever. Okay, almost done here. Number 11 is the conjugate acid of HS. Remember, in a conjugate acid, you need one more H plus. So right here we have one H and one S. So that means we need 2 H's and 1 S. So H2S. And D is the only option for that. Lastly, number 12. Again, you want to find that pair. So H, this is one pair, and this is a pair. And then that's your other pair. So you have H2PO4 and H3PO4 as one pair, and then H2 and OH as the other pair. So again, when you're finding pairs, you want to find things that are similar to each other. And that knocks out A, B, and C, leaving D as the only answer. And if you wanted to go through this further, to label it, H2O to OH, you have to lose or donate H plus. So that makes this your acid and this your conjugate base. And then in order to go from H2PO4 to H3PO4, you need to gain or accept an H plus, which makes this your base and this your conjugate acid. Again, that part doesn't help with the question. As long as you can identify your pair, that is all you need. And that is it for conjugate acid base practice. I hope this was helpful. Tomorrow, we are going to kind of review everything we've done so far. So on that note, have a wonderful day.